Alright, we'll be beginning lecture 3 of trigonometric equations. Basically review of my lecture, what I did today. So I would like to revise few points. There was something called general solutions. Well, because there are infinite possibilities of having same answers for different angles. So if you have an question, say if there's a question is sine x is equal to sine of alpha, we can say that x is equal to n pi plus minus 1 to the power n alpha. This is a bit weird, especially for sine, but alright, There is the next trigonometric ratio, cos x is equal to, sorry, not cos x, is equal to cos of alpha. In this case, x can have values 2n pi plus or minus alpha. This is for cos. If you get in any equation as x and is equal to cos alpha, we can directly substitute as x is equal to 2n pi plus or minus alpha. Next trigonometric ratio we have tan x is equal when it's equal to tan of alpha. This is pretty much easy, as is equal to x is equal to n pi plus alpha, just plus, yeah, there's no minus here. And there are special cases, like these three are the most common ones, and then we have few special cases, namely sine square x is equal to sine square alpha, and then if you have another, like say cos square x is equal to cos square alpha, and also tan square x is equal to tan square alpha. All these have the same general formula as x is equal to n pi plus or minus alpha. So it's almost same as tan alpha with just plus or minus sign. Let's solve few examples now. Well, one example is very simple one. We have sine of 2x is equal to 1 by root 2. Well, we know 1 by root 2 is equal to sine pi by 4. I'm really sorry. So we can say, see, consider this as x and this is as pi by 4, or your alpha value. So we can say 2x is equal to, let's go back and see what it was, just for our reference. It was n pi plus 1 minus 1. Alright? Alright, so 2x is equal to n pi plus minus 1 n and alpha. Here we have alpha's pi by 4, but we need x value, so let's divide both sides by 2. We get n pi by 2 plus minus 1 to the power n upon pi by 8. This is the general formula for x. Let's have another example. Let's see what can we have. Alright, there is an important one here. This is, as we know that, let's see, the question says tan 3x is equal to tan x. Okay, what Asa says is people solve it quite correctly, but in the end they make a mistake. What that mistake is? Well, this is direct, yeah. We can keep this as x and this is our alpha, and very simple. 3x is equal to n pi plus x plus x. So divide both sides by. You could bring this x here. So 2x is equal to n pi and x is equal to n pi by 2. This is your general formula. But if there's an option and you tick, this is wrong. Why? Because, see, let's put a value. Let's put 1, for example, as n's value. You will get pi by 2. And if you put 3, you get 3 pi by 2. I'll tell you why I'm putting just r. Okay, let's put 2 pi by 2, and then 4 pi by 2 is 2 pi. But if you see, pi by 2, 3 pi by 2 is not defined for tan of alpha. It's not defined. It appears to approach infinity. Yes, therefore, all these pi by 2, this you can write this as simply pi. So the general equation will just be n pi, because you see, pi, 2 pi, 4 pi, 3 pi, 4 pi, 5 pi, it goes on. This 2 won't be there. Yeah, this is not defined, it goes to infinity. So that's the mistake. So here's an important note that says if trig equations involve tan, sec, cot, cosec, we should always check after getting the solution. Very important. Well, sine and cos, you might say, hey, what about sine and cos? Well, they are well-defined trigonometric ratios, so they actually all the solutions, they are actually perfectly fine. You won't find any mistakes there. Now we began something called types. So like there are various types of equations. Type 1, we call it reducible to quadratic. Well, what this means is you can convert your trigonometric ratios to quadratic and simply solve like you would do for a quadratic. Quite simple, and you get the solutions very easily. Let's hop in directly to a difficult question. I mean, it's not difficult, but you'll see. Let's for example, I say tan x plus sec x is equal to 2 cos x. Okay, now how do we solve this? Well, convert this into sine and cos. Let's see, sine x upon cos x plus 1 upon cos x is equal to cos x. So the denominator same, let's send it to the RHS. Sine x plus 1 is equal to 2 cos square x. Now, to make it a quadratic, we need to have something in common. So let's convert this cos square x as sine x, because that's barely simple. So 2 times you can write this as 1 minus sine square x, because sine square x plus cos square x is equal to 1. So cos square x is equal to 1 minus sine square x. I hope you know what this means. So sine x plus 1 is equal to 2 minus 2 sine square x. Bring both of these to the LHS. You have 2 sine square x plus sine x. 1 minus 2 is minus 1 is equal to 0. Let's keep this as 2t square plus t minus 1. So let t equal to sine x. Alright, let t be sine x and solve it. You know, it's better simple. You can solve it quite easily. So how do you split this terms? You can, oh well, you see, it can be split into 2t square plus 2t minus t minus 1 is equal to 0. Let 2t is common. So t plus 1 minus 1 t plus 1 is equal to 0. So we can say that t is either equal to half or t is equal to minus 1. Alright. So what was t initially? It was sine x is equal to half or sine x is equal to minus 1. But when we have two solutions as sin x is equal to minus 1 and sin x is equal to half, we should always go back to the question. Why? Because we had tan x and sec x, and according to the note we wrote here, we should always check. So we have tan x and sec x. So let's see, is tan x and sec x, let's just open this up and we'll see. So sin x can also be equal to sine pi by 6. Yeah, half is equal to 30 degrees pi by 6. So we can write this as x is equal to n pi plus minus 1 to the power n pi by 6. And this sine x is equal to sine of, this is minus 1, gentlemen. So because this is minus 1, 270 degrees, yeah. So 3 pi by 2. So we can say x is equal to n pi plus minus 1 to the power n 3 pi by 2. Can you guess which one we should accept and which one we shouldn't? Well, we cannot accept this, and this is correct because if you see, if you put n as 0, this becomes 0 plus 1 times 3 pi by 2, and if x is equal to 3 pi by 2, tan is not defined, and hence a question cannot be accepted. This cannot be accepted. So this is your final answer, gentlemen. So okay, let's move on. And there is a type 2, and type 2, okay, after type 2 there is another one, and we are done for this video. A sine square x plus b sine x cos x plus c cos square x plus d is equal to 0. If you come across any such type of question, divide it by cos square x. What this will do is, see, you will understand. This becomes a tan square x. Sin square x upon cos square x is tan square x, and upon cos square x, cos and 1 cos is gone, and you are left with sine upon cos. So this becomes b tan x plus c cos of it, cos y, it's 1 plus, I think I can write this as d upon cos square x as sec square x, and sec square x can be written as 1 minus tan square x, yeah, is equal to 0. So there you go. We can solve it quite easily from now on because it's just tan square. We can assume tan square to be t and solve it just like a quadratic equation. Let's solve an example based on this because this is an important one and many questions have come. Yeah. 3 sine square x minus sine x cos x minus 4 cos square x is equal to 0. Now, there need not necessarily be a d here. There isn't a d. And there isn't a c either. There's no constant. But well, you have cos square x. Yes, c is there. So yeah, sorry. So let's divide it by cos square x. You see, it you need not necessarily divide it by cos square x. This makes it easier because we have a formula for tan x is equal to n when x is equal to n pi plus alpha. Yeah, we have that, and that's why it's easier for us to solve. I mean, you can divide it by cos sine square x. It's also, but this is easier because we know the formula. So this becomes 3 tan square x minus tan x minus 4 is equal to 0. There you go, quite very simple. Minus t minus 4 is equal to 0. And this can be split as 3t minus 4 t plus 1 is equal to 0. So t is equal to minus 1 or t is equal to 4 by 3. Now, you can simply eliminate it here. Well, you see, tan is defined for this, tan is defined for this. We are good. We can solve both of them. So tan x is equal to minus 1. This is tan x is equal to tan of minus 1 3 pi by 4. Yeah, it's 3 pi by 4. So we can say that x is equal to n pi plus 3 pi by 4. Well, this 3 pi by 4, what that I'm saying, for any value of tan which is equal to minus 1, you can put that here. That angle. It need not necessarily be 3 pi by 4. You can write it as minus pi by 4 as well. So this becomes, this will become, you can write it even minus as minus pi by 4. This is also absolutely correct. Alright, let's move on, and this is also very simple. We can simply say tan x is equal to tan of 53 degrees. Well, this is just an approximation. Yeah, 53 degrees is just an approximation. So don't say that 4 by 3 is equal to tan 53 degree. Alright, so this can simply be written as n pi plus 53 degrees. Now you might be wondering, pi, degree, yeah, you can write it like that. Degrees in this form, in this type, in this formula particularly, you can mix it up. But while if you're adding or something, you have to bring it to degrees or radians. Okay, one JEE question for the day. Let's see, one beautiful question. You wanna see? Okay, I think this one's nice. Let's see. Yeah, this one's quite interesting. This is a JEE advanced question in 2019 paper. So the question goes like cos 2x plus alpha sin x is equal to 2 alpha minus 7, and they are asking alpha belongs to what? What range of alpha do you get for so that you get just one solution for this quadratic? Well, it's barely simple. Well, you will understand what we have to do here. Let's first bring alpha on one side and everything else on one side. So I can write cos 2x as 1 minus sine. Okay, sorry. 1 minus 2 sine square x, and bring that 7 here, plus 7 is equal to 2 alpha minus alpha sine x. Yeah, see, we have alpha together here. So 1 minus, oh sorry, oops, 1 plus 7 is 8 minus 2 sine square x is equal to alpha 2 minus sine x. There we go. Now bring this 8 minus, okay, I'm gonna do it a bit quick because this is getting lengthy and I'm not being so conservation of time. It's very important. I'm just skipping a few steps. Alpha 2 minus, okay, more skipping of, I'm bringing this 2 minus alpha to LHS. 2 minus sine x. Okay, no more skipping. 2 plus sine x, because 4 minus sine square x is 2 square minus a square minus b square. So a minus b, a plus b is the formula upon 2 minus sine x. Now, because 2 minus sine x is not like equal to 0, we can cancel it out. And there you go. 2 plus sine x is equal to alpha. Yeah. Our next step would be to find the range of alpha. So we know sine x is between 1 and minus 1. So if you just open this, this becomes 4 plus 2 sine x. Yeah, sine x. And please understand. Okay. If I multiply it by 2, minus 2 sine x, to add 4 to it, to the whole equation, add 4. So you would get minus 2 plus 4 is 2. 4 plus 2 sine x is 6. Therefore, alpha belongs between 2 and 6, including both of them. And thank you very much for coming in. This was my today's review.